Shri Gurubhyo Namaha, children. Welcome you for the online teaching academy, Ekalaiva. Today we are going to continue with 10th standard science, acoustics. Today we are going to discuss on echoes. Hope you are very familiar with this word, children. What are echoes? An echo is nothing but the sound reproduced due to the reflection of the original sound from various rigid surfaces. Now let me write here, what is an echo? Now it is the sound reproduced due to the reflection of the original sound from various rigid surfaces. Now you would have observed this phenomena many times. Suppose imagine you are on a closed room. Okay, the room is a very spacious room. Now when you go and make some noise, you will be able to hear the echo of it. And when you go and stand on the surface of some mountains, if you give a clap, if you make a sound, it will be reproduced. You will be able to hear back the echo. Okay, so this is the nothing but the reflection of the original sound wave, and this sound wave, it will go and just touch a rigid surface, and then once again it comes back and it will be heard as an echo. Okay, now there are certain conditions necessary for hearing an echo. Now, first one is the time. You should know what is the minimum time gap between the original sound and an echo. Okay, so that should be considered. And the second one is the minimum distance required to hear an echo. So these two things are very important to hear an echo. So let us first start with the time gap. Okay, so we can hear two sound waves very clearly if the time interval between the two sounds, okay, is 0.1 second. Okay, which means, now which is nothing but, you call it as persistence of hearing. Persistence of hearing. Now what is persistence of hearing is, it is the sensation of hearing of any sound that is staying in our brain. The time for that is 0.1 second. Okay, so it stays in our brain, or it should be there, so that you will be able to hear the next sound wave. So the time interval between the two sounds should be 0.1 second, which is nothing but, you call it as persistence of hearing. The persistence of hearing of human here is 0.1 second. Which means the time gap between the original sound and an echo, it should be minimum 0.1 second. Only then you will be able to hear an echo. Okay, ma? And the second one is the distance. So what should be the minimum distance? That we are going to calculate now. Now let us imagine a source of light here, children. Sorry, source of sound. Okay, a source which produces sound wave. And imagine, let us consider a mountain here. Now you just make a sound. Okay, the source is producing a sound. Now this sound wave, it travels all the way to the hill, and then once again after reflection it comes back. Yes or no? So what is the distance? Okay, that is the distance between the source of sound and the reflecting surface. And imagine, and an observer is here. okay, who is just receiving the sound back. So you can calculate, now we know the formula for velocity. Now what is the formula for velocity? Velocity is nothing but distance traveled by time taken. I need to know what is the distance between the source and the reflecting surface. Okay, so I rearrange this formula. So what is now the value of distance you will be substituting? Let us consider this distance as d, and again what is the time taken by the sound wave, the distance covered by the sound wave while it is reflecting from the surface. So this will become 2d now. That will be the total distance covered, and an observer who is standing near the source will be able to hear the sound back. So the distance traveled by the sound wave is considered to be 2d, and the time taken will be t. So I wanted to find out the distance now. So let me rearrange this formula. So when I rearrange this formula, now distance will be d is equal to v into t by 2. Okay, I know the value of t to be 0.1 second divided by 2, and as I told you in my earlier video, the velocity of sound in air, what is the value, children? Velocity of sound in air is 344 meter per second. So I'm going to substitute that value here. So when I substitute, d is equal to 344 into 0.1 divided by 2. Now this will be, or I can also write this as, when I substitute, I will get the value to be 17.2 meter, which is the minimum distance required to hear an echo. Is it clear? So the first condition is the time interval. The time interval between the two sounds is 0.1 second, and what should be the minimum distance is, the minimum distance required to hear an echo is 17.2 meters. So these are the two conditions that are necessary for hearing an echo. Okay, ma? Next we are moving on to the applications of echo. So what are the main applications here? They have discussed 3 applications, children. One is, the first application is animals. Animals communicate over long distances by sending the sound signals and receiving the echo, and the echo will be reflected from the target, so they are able to locate the objects. So by sending these sound signals, they will be able to locate the objects. So this is how animals communicate over long distances. Okay, and the second use of echo is, now this principle of echo, that is the reflection of sound waves, is used in obstetric ultrasonography. Okay, now this is used to create visual images. Okay, in mother's womb you have fetus. Okay, if a mother is pregnant, she has an embryo or fetus in her womb. So that is that images of those developing embryo is got by the principle of echo, and this is considered to be a safe testing tool, as it does not produce any harmful radiation. So this method is used to view the images of the developing embryo. Okay, so this is the second use of echo. And the third one is, which is used, echo is used to determine the velocity of sound waves in any medium. So how to measure the velocity of sound waves by echo method? That is our next topic. Okay, so again let us consider a source here, children. Okay, this is a source which is producing a sound wave, and you just take some, again you will have here as per your textbook, whatever they have taken is a source which is producing a sound pulse, then a measuring tape, then a sound receiver, and a stopwatch. Okay, so Now let us consider a reflecting surface here. Okay, this is a reflecting surface. Now a source which is producing the sound, right? Now you measure the distance between the source of sound pulse and the reflecting surface by a measuring tape. Now let this distance be d. Okay ma? So this is the distance, right? Okay. Now now you will the source will emit a sound pulse. Okay, now as soon as the source is emitting the sound pulse, immediately switch on the stopwatch. Okay, and calculate or note the time interval from the instant at which the sound pulse is sent and received. So the time interval is noted as t. Okay, and you can repeat this experiment for 3 or 4 times and note down the average time taken for the number of pulses. Okay, so what is the distance? The total distance will be total distance traveled by the sound pulse. Okay, it is taken as 2d. Now the sound pulse will travel a distance d, reaches the reflecting surface and then come back. Okay, so the total distance covered will be 2d, and the time taken, what is the time taken? The time taken will be measured as t second. So I can calculate the speed of sound or velocity of sound. Speed of sound, again we know the formula. Speed of sound is nothing but distance traveled by time taken. Okay, so the distance traveled is 2d and the time taken is t. So this is the formula to determine the speed of sound. Okay, so these are some of the applications of echo. So first application is for the communication. Echo is used to for communication among some animals. Then it is used in ultrasonography, and it is also used to measure the velocity of sound in any medium. So this is about echoes, and we are moving on to the applications of reflection of sound. So here are some instruments which are used like where you have the reflection of sound that is taking place. So the first one is, in your textbook they have given sound boards. Okay, so actually sound boards are nothing but curved surfaces, usually concave surfaces, now which are used in halls, very big halls. To improve the quality of sound in very big halls, we go for this basically curved surfaces which are concave in nature, right? So the board is placed in such a way that that the speaker should be at the focus, okay, of the concave surface. So the sound of the speaker will be reflected, and the audience who are there in the room will be able to hear a very clear sound. Okay, so they will be able to hear a very clear sound where you keep the speaker at the focus of the concave surface. So so sound boards. Okay, then the second one is ear trumpet. So this is a ear trumpet, children. So this is again a hearing aid, now which is used by people who have difficulty in hearing. So they will not be able to hear properly. So they use these kind of devices. This is called as ear trumpet. Okay, now here in this device, one end of the device is wide and the other end is narrow. Are you able to see this? So this is a narrow end, this is a wider end. Now what happens here is the sound from the source falls into the wide end and are reflected inside the walls and reaches the narrow part of the device. So what is happening here is the sound waves are concentrated and the sound enters the eardrum with more intensity, because inside the walls of this trumpet the sound waves are focused or concentrated, and the person will be able to hear it very, very clearly. Okay, so this is the use of ear trumpet. And finally megaphone. Again, this is a you would have seen this everywhere, wherever you have gathering of people, public meetings, very small gathering of people, they use this megaphone. Okay, so this is again a horn shaped device which is used to address a small gathering of people, right? Again, its one end is wide, the other end is narrow. Okay, now the person who is speaking, he will speaks at this narrow end, and the sound of, again, the sound of his speech is concentrated by multiple reflections inside the tube, and when it comes out, it comes out as a clear voice, and this will be able to, I mean, people who are standing there will be able to hear the voice very clearly. So these are some of the applications of sound. Okay, so see you in our next video, children. To receive our online lessons, please press the subscribe button, and you will receive the latest updates. Thank you, children.